So basically, the chi-square test is a statistical test that we use in order to determine in an experiment whether your outcomes are significantly different than what you expected previously. So we use this a lot in biology to determine whether offspring of certain parents, if something went wrong in the experiment, or whether or not we don't know the genotypes, or basically if something went wrong. So we start this off by making a table, and the table we correlate it with this equation, which we call a chi-squared equation. And the chi-squared is equal to, this symbol means the sum of observed minus expected squared over expected. So we look at the table, and we notice that we categorize it in 4 ways, which is the different types of phenotypes. We have gray bodies with long wings, gray bodies with short wings, ebony bodies with long wings, and ebony bodies with short wings. These are the different types of phenotypes that we have in this cross. Obviously, some may produce more, some may produce less. So our observed value is basically, we did cross 2 parents, and these are the phenotypes that we actually got. And so what we expect is basically 16. But how did we get to that number? What we did was, we did 4 over 16 because they give us a ratio of 1 to 1 to 1 to 1. Meaning that since there's 2 traits, we're going to be doing a dihybrid cross. And in the dihybrid cross, there's going to be a total of 16 boxes. And so what happens is that if each category has a 1 to 1 to 1 ratio, it means that each box will have a total of 4 boxes. So 4 boxes for this, 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 and this. So we do 4 over 16, which simplifies to 1 over 4, times the total population that we got from our observed, and then we're going to get our expected values, which is the same all across because each of them have the same ratio. So then we have our O minus E squared over E. So we plug in numbers and we get all these different types of values. So what's going to happen is that because our equation says the sum of, we're going to have to add all these, and we're going to get our chi-squared value of 1.25. So now once we have our chi-squared value, what are we going to do with this? We're going to go to a chart, which is usually given to you, and I've omitted parts that we don't necessarily need, so I've just cherry-picked what we're going to use. So because we have 3 degrees of freedom, our critical value is going to be 7.82. But how do we get our degrees of freedom? Well, because there's 4 possible outcomes, or in this case phenotypes, we're going to always get our possible outcomes here, 4, subtract by 1, and then get 3. So 3 degrees of freedom, which affects later your critical value. Our critical value is 7.82. And we notice that our chi-squared value is significantly less than our critical value. So what does this mean? If it's less than the critical value, we're going to accept our null hypothesis. And our null hypothesis was there's no significant difference between the observed and expected values when crossing the 2 parents of cross 3, which is the problem that was given to us. So in the end, we're going to accept our null hypothesis that there is no definitive significant difference between the observed and expected values.